Hello and welcome to part 2 of this video tutorial using SPSS to conduct a mixed design ANOVA. Within a mixed design ANOVA, we're looking at both within and between subjects components, and within this particular analysis, when we have a significant interaction, some stuff we want to know is for which groups are we seeing significant score changes. And in this particular example, we had 3 groups. Group 1 was the blue line. This could maybe be a control group. Group 2, it's the red. And then group 3. So the second and third group could be some kind of treatment groups by which we are exposing students, clients, physicians, patients to certain types of learning experiences, and we're interested in how that might change perceptions, practices, self-beliefs over time. And what we had here is 4 time points. And so within this analysis, we did see overall significant within subjects effects. So, overall scores did change over time. We saw a main effect for group, meaning that, not all the groups scores are the same. They do differ. And we also saw a significant interaction, meaning that the change in group scores over time were not the same. And so one of the follow-up tests would be then, okay, so for which of the groups did we see significant score changes? Was it across all 3 groups, or was it just for one particular group in general? So in essence, what we're going to demonstrate here is kind of like a post hoc analysis to more fully understand, was it group 1, did their scores change significantly over time? Visually, it looks like they would, where they started off with an overall mean of, looks like a little over 10 at time 1, and then it kind of went up to maybe a score of 18 at the final time point. Likewise for group 3, for example, they looks like they may have scored maybe 11 or 12 at time 1, and then went up to maybe 28 at the final time 4. And so what we want to do here is just kind of tease apart the data to see which of these 3 groups has significant score changes over time, which ones may not. Because, for example, group 1, their scores this may not be a statistically significant difference from the final time point to the beginning, or it might just been we had this increase here that was significant, but the change from time 2 to 3 was not significant, and from 3 to 4 may not have been significant. And similar questions for each of the other 2 groups. And so what we're going to do is, how do we go about looking at this? What this requires is a little bit of data manipulation, and essentially what we want to do is split the file for each of these groups and just simply run a within subjects ANOVA, which will report findings for each of the groups separately. It'll just aggregate the data. And so when we want to divide the data out with the groups, we can use data split file. We're going to split the file, then we're going to organize the output by group. Okay, so everything that we did, if we ask for a frequency, if we ask for measures of central tendency, variability, it's going to be done for each group individually, and we'll be able to inspect that data, the output for each of the groups. And so once we identify that, we click OK. Go to Analyze, because now we want to conduct this post hoc analysis, and it's going to be repeated measures. What we want to do is reset this, because we're not doing a mixed design like we had before. So we have 4 levels. Define it. And we have each of our 4 time points. We can ask for plots, so we can ask for, it's going to give us 3 different graphs, 1 for each group. And then the option, we can ask for our sphericity assumption, descriptives, effect size. And we're not going to add anything for the between, because we're not comparing between. Right now we're just doing a within for each of the groups individually. Okay, so what we find when we do that split file is, so we hear the general linear model, group 1. So we're going to be looking first at the group 1 findings. So for group 1, We see we've met the sphericity assumption. The p-value is greater than 0.5. We come to our test of within subjects effects, and we do see the scores do change significantly over time. And I think one of the things I just forgot to do here is specify the contrast statement. And so what I would like to do then is go back to analyze, repeated, the contrast, because what we want to know is where are these score changes happening. So I'm going to pick repeated and change it, continue. I'm just going to rerun this real quick, so we're going to start over here. So again, for our group 1 results, we come to the test within subjects. We've met the sphericity assumption for group 1. This was our control group. And we see that their scores do change significantly over time. And so what we want to know then is where do they change over time? And so what we see here then is interesting is level 1 versus 2 does not look like there's significant score changes. 2 versus 3 and 3 versus 4. And so what we can kind of conclude here is that based off just this group though, is that these are not significantly different. Instead, what may be flagging this significance level here is just the overall change maybe from time 4 and 3 from time 1. So within this repeated instance, for example, we're not seeing differences between 2 and 1, 3 and 2, and 4 and 3. Instead, maybe we want to do like a simple contrast where we're comparing scores back to the baseline. But if we look at the incremental change from time 1 to 2, we're being indicated that that's non-significant. Likewise, from 3 to 2 is non-significant, and 4 to 3. Alternatively, we might want to do a contrast that compares scores back to time 1, if that's our research question of interest. Okay, but in terms of incremental changes, those are non-significant for group 1. For group 2 then, we've met the sphericity assumption. We see here with an F statistic of 78, our p-value is significant, so we can conclude that there are score differences over time. And what we see here then, a little different story for group 2, is a level 1 versus 2 is significant, 2 and 3 as well, but then the difference between 3 and 4 is non-significant. So let's look at this graphically. So our scores from 2 to 1 are significant, statistically significantly different. Specifically, group time 2 scores are statistically higher than time 1. 3 are statistically higher than time 2. However, 4 and 3, time 3 and 4 scores are statistically similar, as we see here with the p-value. Okay. And so again, the type of contrast you want to use really depends on what your research question is. If you're looking at incremental changes over time, if that's where your focus wants to be, this would be the contrast. If you want to go and compare times 2, 3, and 4 scores back to time 1, if this is like a baseline measure to see at what point are scores statistically increasing, then that would be a separate contrast. I believe the simple, for example, would be used. For group 3 then, we see we've met the sphericity assumption. We see that the score differences are significant over time. And what we see then for group 3 then is time 2 and 1 are statistically different. So time 2 scores are statistically higher than group 1, time 1. 2 versus 3, we have a p-value of 0.09 if we round off. So those would be considered statistically equal, time 2 and 3 scores. And then we compare level 3 and 4, 3 and 4. We have a p-value of 0.09, so we conclude that these are statistically the same. So once we account for the incremental change from time 1 to 2 for group 3, that's a statistically increase in score. However, once after time 2, we see that these scores are statistically equal. And so again, if that corresponds to your research hypothesis, your question in terms of incremental changes, using the repeated contrast would be the appropriate analyses in this